now that we know what a function is, we can start talking about what domain and range is and how to find it. Domain and range are very fancy names for a simple idea. So the definition of a domain is the set of all possible values of the independent variable, which is typically x. And the range is all the possible values of the dependent variable, which is typically y. What that means is domain is what is x allowed to be? What is x allowed to be? And the range is what is y allowed to be? So one more time, domain is what can x be, and range means what can y be. So let's try this example. What is the domain and range of this? So we took a look at this when we were defining whether this was a function or not. We did that in our last video. We found that this was a function because every x only had one y. But what is x allowed to be? Well, we can assume that this relation that we're given here, this is it. This is all the information that we know about this thing. So what x can be is 0, 1, 2, 3, 4, 5. That's the domain. And the range is what can y be? Well, here's our y, or our dependent variable. And what can y be? Well, y can be 0, 4, 6, and that's it, because 4 and 0 we already counted. So y can be 0, 4, and 6. So if we can say what the domain and range is, that's a great start. Now can we write it? There's a particular way that we write domain and range. So there's different ways to write it. We're going to use something called set notation. So to start, if we are going to list out the domain, we start with writing a D and then a colon. Then we're going to use these squiggly brackets like this. And we are going to write what x can be, or in this case t, so the independent variable. And x, or t, can only be a certain, these particular numbers. So if that's all that t, or x, in this case it's t, can be, we're just going to list that as what is in the domain. So in the domain are the x value the x or t can be 1, 0, 1, 2, 3, 4, and 5. That's it. And how about the range? The range is what is y, or in this case h, allowed to be. So let's start it off. To write it in set notation, we start with an r and then a colon, and then we have this squiggly bracket here. We're going to list all the values that y can be. In this case, it's 0, 4, and 6. I'm not going to repeat 4 and 6 again, or 0, because it's already there. So here we've written the domain and range in set notation, and we're done. How about if we have a mapping diagram? Domain is what is the independent variable allowed to be, here they are, and range is what is the dependent variable allowed to be. In our video on functions, we learned what this notation means and how to write it as points if we wanted to. This is the point 1, 6, and we have 2, 6, and 3, 5, 4, 4, 5, 4. So to list what's in the domain, we're going to start with a D, and then we're going to do a squiggly bracket, and we're just going to list out everything that x can be, which case is 1, 2, 3, 4, 5. Done. And how about the range? Well, in the range is only 4, 5, and 6. And it's literally that easy. So it gets a little bit more complicated when we have a graph. So let's try a graph. So this is a graph, and it just consists of individual points. So this is called a discrete graph. graph. If it's all connected with a smooth line or curve, that would be called continuous. So a discrete graph just means that x and y can only be these particular points. So coming up with the domain and range of this is actually quite easy. So I'm going to start with the domain. So we're going to write D. We have our squiggly brackets, and we're just going to ask ourselves, what can x be? So I'm talking about x here. So let's take it point by point. Here, x can be 1. Here, x can be 2. X can be 3, 4, and 5. That's it. So x can be 1, 2, 3, 4, and 5, and that's it. And how about the range? What can y be? Start up here. What's y here? It's 6. Here it's 6 again. Here it's 5. Here it's 4. So it can only be 6, 5, and 4. So that's how I'm going to write my range. 6, 5, and 4. I'll go in ascending order. And we're done. Now, how about a graph like this? We are trying to find domain and range. So what can x be and what can y be? So let's start by figuring out the domain. So I'm going to start with a D, a colon, and a squiggly bracket. And then we got to really think about this. What is x allowed to be? So if you're not sure where to start, I like to start at 0 and ask myself, is x allowed to be 0? Well, let's pull it up and see if it hits the relation. Yes, x can be 0 because it gives us a y value of 5. How about 1? Can x be 1? Yep, it hits the relation. Can x be 2? Yep, this is the point 2, 3. So definitely x can be 2. How about 3? Yep. How about 4? Yep. How about 5? Yep. How about 6? Yes, it still hits the relation down there. A point on the line is 6, -1. 7, yes. 8, yes. -1, yes, yes. And there's arrows here. This is going to continue on forever. So even if it goes all the way down here and I ask for when x is 100, eventually it will hit this line. So my question is there anything x can't be? So how about a tiny little decimal? Can x be 0.5? Yep. How about like 0.4 or 0.11111? Yes. Because this is a continuous graph, this means that x can be any tiny little number. So in the previous examples that we did, x was only particular numbers. It couldn't be anything in between. So for example, in this guy here, x couldn't be in between 1 and 2. It could only be 1 or it could be 2. But here it could be 1, it could be 2, or it could be 1.5 or any number in between. So this makes finding the domain and range of a continuous graph a little bit more difficult, but we have a system. So if x can be any tiny little number, we write it like this. We say x is an element of all real numbers. And this R with the double line signifies the words or the idea of all real numbers, which means that x can be any tiny little number that we can come up with. So x can be 0.22224367718 and continue. X can be anything is what I'm trying to say. And in this particular case, there's no restriction on x. X can be absolutely anything. X is going to keep, or this line is going to keep going down this way, and it's going to keep going up this way. It's going to hit every single x value possible. So this is what we leave the domain as. We say x is an element of all real numbers, and that's it. And what that means is that x can be anything. That's what this means. X can be absolutely anything. How about the range? So I'm going to start by putting R, and let's take a look at y. What is y allowed to be? And if you don't know where to start, try starting at 0. So I'm going to, here's our y-axis. So I'm going to go across here. What can y be? Can y be 0? Yep, because the 0.50 is on this graph. How about 1? Can y be 1? Yep, because the 0.41 is on the graph. How about 2? Can y be 2? Yes, it can. How about 3? Yes. How about 4? Yes. How about 5? Yeah, the 0.05 is on here. How about 6? Yep, here it is. And we can go to the negative numbers. -1 can be -1, -2, -3. Are you seeing the pattern? That this line is going to continue on forever. So y is going to be able to be anything, -1,000,000. It can be -1,000,000. And it can also be +1,000,000 because this line is going to continue up, 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 up to the left. It's going to hit every y value possible. So what we really want to say is that y can be anything, any tiny little number. It can be in between 4 and 5. It can be 4.127, blah, blah, blah. So to say y can be anything, we use the same notation. We say y is an element of all real numbers, which means that y can be any possible number that we can come up with. Let's try this continuous graph. So I want to know what can x be and what can y be. So again, this is continuous because it's one smooth curve. It's not individual points. So x and y are going to be able to be a lot of different things here. Let's start with the domain. So let's ask ourselves, what can x be? So if you're not sure where to start, you can start at 0. So I'm going to go up, 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 see if I hit the relation. Yes, x can be 0, because when x is 0, y looks like 7. Can it be 1? Yep. 2? Yes. 3? Yes. 4? Yes. We're going to keep on going, keep going. Can it be 6? Doesn't hit, but we know that there's arrows on the end of this, and we know this is just a parabola. So it's going to keep going, 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 going. So just in future, when you're looking at graphs, unless there's a big point, like a dot, to signify this is the end, you can assume if a graph goes right to the edge of the graph paper or the sheet, that it continues on, unless there's a big dot to show you that it's done. So this problem is going to keep going, 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 going. So x can be 6. Eventually it is going to hit this problem, maybe up here. How about 100? Can x be 100? Yes, this problem is going to keep going up, 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 all the way up, and so it will hit 100 all the way over here. How about negative numbers? Can it be -1? Well, yeah, it hits the parabola right there. How about -2? It's going to hit the parabola if it continues up here. How about -100? Yes. So what is this conclusion? Is there any restriction? Is there anything that x can't be? No. X can be absolutely anything. It can be +100, -100, everything in between. So we know how to write that. We just say that x is an element of all real numbers, which means x can be anything. How about the range? All right, let's take a look. What can y be? So I like to start at 0. So can y be 0? Let's go this way. Do we hit the relation? Nope, the relationship all the way up here. How about on this side? No. So can y be 0? It doesn't look like it. How about 1? Can y be 1? Also doesn't hit the relation. How about 2? Can y be 2? Nope. How about 3? Oh yes, it can be 3. It hits the relation right there. So the point 2, 3 is on there. How about 4? Yes, it hits the relation twice. So y is definitely allowed to be 4. How about 5? Twice again. 6. Yes. 7. Yes. 8. So what can y be? Can it be anything? No, because it can't be any numbers down here. So it can't be any numbers below 3. So let's just put a little note that this guy is 3. And that was our first y value. So how do we write that? Y can be anything, but it can't be less than 3. First, we start off with this notation. We're going to start off with the fact that y is an element of all real numbers. But we're not going to be done. The reason why we're going to write that is we're going to say y can be any tiny little number. Y is not just 3 or just 4 or just 5. It can be anything in between 3 and 4. It can be 3.3332222, whatever you want. So y can be any tiny little number. But we do this line. This line means such that. Such that. Or another way to remember it is but. It's like y can be anything, but actually, what's the restriction on y? Instead of saying that y can't be less than 3, we always try to write it in a positive way. We say what y is allowed to be. In this case, y can be anything that's bigger than 3. So we write that y has to be greater than 3. Whenever you write a greater than or less than sign, you want to ask yourself, can it also be equal to? So taking a look at 3, can y also be equal to 3? Well, yes, it can, because the point 2, 3 is on this parabola. So we're going to do an equal to sign and then close our bracket. So let's just confirm what we said. We said that y can be any tiny little number. Y is an element of R, or such that, but y has to be greater than or equal to 3. And that's what this says. Y can be any tiny little number, but y has to be bigger than 3. So we're done. Let's try one more example. I saved the hardest one till last. So we can see that this is a circle. And the question is, can we come up with the domain and the range? So, what can x be here? So I can see, let's start with 0. Can x be 0? Yep, it hits the relation 2 different points. How about 1? Yes, it can be. 2, yes. 3, yes. 4, yes. Can be 5. Yes, the point 50 is on there. How about 6? No, it cannot be 6. Let's go on the other side. -1. Can be -1. Yes. -2. -3, yes it can. -4, yes. -5, yes, because -50 is on this circle. How about -6? No. So x can only be between -5 and 5. So how do we write that x can only be between -5 and 5? Well, first of all, this is continuous. So, which means that x can be any tiny little number in between 0 and -5 and 0 and 5. So we're going to start it off by saying that x is an element of all real numbers. But there's a restriction because x has to be between these two numbers here. So there's a very particular way that we write it. We always write the lower, if x or y has to be between two numbers, we write the lower number first and the bigger number second. So start it off like this, -5 and 5. And in between, you're going to put the letter we're talking about. In this case, it's x. And then you have to put these symbols in between. You have to put 2 less than symbols. What this means is -5 is always going to be less than x, and x is always going to be less than 5. So just remember, when x is between two numbers, it has to look like this. The two numbers have to be written on the outside, and that has to be the smaller one first and the bigger one second, x in the middle, or y if we're talking about the range, and then less than signs. But every time we write an inequality, we always ask ourselves, should there be equal signs here too? So can x be equal to -5? Let's take a look. Yes, x can be equal to -5. So I'm going to put an equal to sign underneath. And how about over here? Can x be equal to +5? Yes, it can. So I'm going to put an equal sign underneath. And we're done. Let's try the range. So try the range on your own now that you know everything you need to know. Pause the video and then come back once you think you have it. So if you are here, you have tried it on your own. If you haven't, pause, don't listen to me, try it on your own, then come back. So if you've tried it on your own, you can see that this is a continuous graph. So we're going to start off with y is an element of all real numbers. Y can be any tiny little number, but what does it have to be between? Well, y can be 0, it can be 1, 2, 3, 4, 5. Same deal with the x. Y can be 5, but nothing bigger. It doesn't hit the relation anymore. And the same with the negative here. It can be -2, -3, -4, -5, but nothing lower. So y has to stick between +5 and -5. How do we write that again? First of all, we got to put the smaller number first. So start with the -5 first and then the +5 last. And then in the middle is the letter we're talking about, in this case, y. And then always, 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 we have to use less than signs. Here we go. 2 less than signs. Then we're going to ask ourselves, can y be equal to -5? Let's check. Yes, it can be. The point 0, -5 is on this relation. It's on this circle. So I'm going to put equal to sign. And how about positive 5? Can y be equal to positive 5? Yes, it can. I'm going to put an equal to sign, and we're done.